Welcome back, everyone. Get ready because this explainer is an absolute game changer. We are taking an exclusive, behind-the-scenes look directly inside the examiner's mind for Cambridge Computer Science. Whether you're tackling syllabus 0417, 0478, 0983, 0984, 2210, or braving the advanced depths of 9618, we are setting up the ultimate challenge today. We're going to decode the reality of general-purpose versus special-purpose registers. Look, if you've ever opened an exam paper, stared at a massive, complex question, and felt like you were looking at an impenetrable wall of text, you are entirely in the right place. We're going to shatter that wall today. Because here is the secret. There is no paper. There are only patterns. And by the time we wrap up this session, you're going to learn exactly how to see the code behind every single question they throw at you. So, let's jump right in.
Here's our roadmap for today. We're starting with the challenge to identify where things go wrong, moving into the strategy reveal, showing you the transformation, getting hands-on with an interactive workshop, and wrapping it all up with the final system. Let's go. Act 1, the challenge. We have to start here because general purpose versus special purpose registers is consistently, and I mean literally every single year, one of the most misunderstood areas across the entire Cambridge Computer Science syllabus. Let's figure out why. To really understand the root of the problem, we have to ask a tough question. Why do smart students find multi-step calculations and grabbing those method marks so incredibly hard? Well, to explain this, let me introduce you to two classic candidate archetypes we see in the exam hall all the time. First up, we have Alex. Now, Alex is absolutely brilliant at memorization. Alex knows the textbook inside out. But when it comes to the exam, Alex tends to overload answers with raw computer science facts without actually providing any analysis. Then, on the other hand, we have Sam. Sam definitely knows the material, understands the concepts, but panics. Sam rushes through the execution and entirely misses the specific requirements of the command words in the prompt. Both of these students are losing critical marks, but they're losing them for completely different reasons. Look at this. When we put their flawed approaches side by side on a real past paper question, it reveals so much. Alex has written this massive, incredibly detailed paragraph detailing every single thing they know about registers. I mean, it's a data dump. But here's the catch. It doesn't actually answer the prompt. Sam, however, has gone the other way. Sam just jumps straight to the final answer, completely ignoring the show how command word. Because they aren't seeing the structural patterns behind the question, both Alex and Sam are leaving massive points on the table. They are missing critical method marks. And you have to remember, Cambridge awards method marks for the process, for the logic, not just for stumbling into the final destination. Act 2, the strategy reveal. Before we continue into the exact architecture you need to fix this, subscribe to our YouTube channel, Ace the Exams, at AC Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's dive into the core principles. The theoretical architecture of general purpose versus special purpose registers rests on two things: precise definitions and causal relationships. You literally cannot afford to be vague here. You need to clearly delineate what general-purpose registers do, right? They hold temporary data and instructions during processing. And you have to contrast that with special-purpose registers, which have highly dedicated, incredibly specific functions within the CPU cycle. Establishing this fundamental theoretical architecture and clearly contrasting their roles rather than just listing them is exactly what Cambridge Computer Science demands for mastery. If you don't show the contrast, you don't get the marks. Simple as that. So, you might be wondering, how on earth do we structure that theoretical knowledge perfectly under exam pressure? Well, this brilliantly illustrates the solution, the PEAL framework. Point, evidence, explanation, link. Top students don't just write, they structurally encode their answers using this exact method. First, you make your point about a specific register. Then you provide evidence extracted directly from the given scenario. Next, you write out the explanation of how it works causally. And finally, and this is the one everyone forgets, you link it back to the specific question asked. This is how you prove to the examiner that you have a connected, conceptual understanding rather than just vomiting memorized textbook facts onto the page like our friend Alex. And the absolute crucial element that ties all this together is cross-topic connections. The syllabus explicitly, heavily emphasizes that top-performing students exhibit a connected understanding that transfers to totally unfamiliar contexts. Examiners don't just want to know if you can define what a register is, they want to know if you understand its causal relationship and how it integrates with other areas of the syllabus. For instance, can you connect register functions to algorithmic efficiency? Transferring your conceptual understanding to these weird, unfamiliar contexts they throw at you is the true secret to unlocking those top-tier grades. That's the matrix code right there. Act 3, the transformation. Okay, We've talked about the theory, but now we're moving into the practical methodology phase. Let's look at how the computer science success blueprint actually turns those harsh red pen marks into beautiful green check marks. Here it is. This is your ultimate problem-solving framework. Step 1. Deconstruct. You absolutely must identify the given information and break the massive question down into logical, bite-sized steps. Step 2. Solve. You execute your analytical framework systematically, and you do it using perfectly clear notation, no scribbles. And step 3. Evaluate. You step back, check your answer for reasonableness, and make justified recommendations. Deconstruct, solve, evaluate. Guys, this is the exact sequence that secures maximum method marks every single time. It's foolproof. Let's actually see how this builds in a real scenario. Look at this before and after. In a complex multi-step calculation, a rushed answer, like Sam's, yields just a final value. That score is what, maybe 1 mark out of 4? But by applying the deconstruct, solve, evaluate method, we transform the answer. We break the calculation into visible, highly logical steps. We explicitly show the initial data extraction, we show the binary conversion process, and we clearly state the final state of the register. This structural change directly adds method marks because it physically proves to the examiner exactly how your logic was processed. You are showing your work, but in a highly structured way. And guess what? This exact same procedural framework applies directly to your programming skills too. When you are dealing with algorithmic thinking, you have to use step-by-step decomposition. You design the algorithm, you implement the solution by selecting the appropriate data structures, you test it rigorously, and then you evaluate its performance. It's an endless, beautiful loop of logical refinement. And honestly, understanding how data physically flows through those registers we just talked about is absolutely critical to evaluating that overall algorithmic performance. They are totally linked. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Act 4, Interactive Workshop. All right, it is time to put all this theory into serious practice. We're going to dissect actual data taken directly from the principal examiner reports. Let's start by looking at the biggest pitfalls. We've extracted the top 3, absolute most critical examiner warnings directly from the official reports regarding registers and problem solving. Number 1, vague answers lacking specific technical details. Don't be vague. Number 2, students completely forgetting to check boundary conditions and edge cases. And number 3, answers that are completely lacking the question's context. Let me really emphasize number 2 for a second. If you omit boundary conditions when you're testing an algorithm or when you're calculating a register's extreme limits, you are literally destroying your algorithmic problem-solving marks. You absolutely must test the extreme. Now, pay really close attention to this high-contrast examiner alert right from the source. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. So, what does this mean for you? It means higher-order assessment objectives in Cambridge absolutely demand that all your fancy theoretical knowledge of general and special-purpose registers be applied contextually. If the exam question is about a washing machine's embedded system, your answer about the status register better be talking about water levels and motor speeds, not just generic binary flags. Context is everything. Let's look at a data scan challenge. In the real exam, under immense time pressure, you will be faced with raw, confusing binary representations. Your critical skills here are to systematically extract that data accurately, perform the necessary calculations, whether that's 2's complement or logical bit shifts, and then draw concrete, evidence-based conclusions about what that data actually represents in the system. Extracting the core trend from these binary representations systematically is absolutely vital to securing full marks. Do not skip steps, even if you feel rushed. The 60-second timer is ticking, but your process must remain flawless. Act 5, the final system. Okay, we've diagnosed the challenges, we've transformed our approach, and we've looked at the examiner warnings. Now let's summarize the masterclass system that guarantees your success. When you are breaking down comparative analysis, like when a question asks you to compare general and special purpose registers, it is not enough to just list their features side by side. You must explicitly identify similarities and differences. You need to use specific comparative connectives in your writing, words like whereas, similarly, or in contrast. You have to support each comparison with hard evidence from the given scenario. And finally, draw conclusions about their relative importance to the specific system being asked about. That, my friends, is exactly how you hit those elusive higher-order assessment objectives. So, to wrap this up, the complete computer science answering system boils down to these 3 golden rules for top marks. Rule 1, command word decoding. You have to know exactly what evaluate, compare, and describe actually require from you. Rule 2, Peel framework application. Always structure your written answers with point, evidence, explanation link. And Rule 3, the time management matrix. You must allocate your time based on the method marks available on the page, not just based on how much you happen to know about the topic.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. You can't just watch this once, you have to put it into practice.
Here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by without having these strategies in your toolkit.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. I'm going to leave you with this final provocative thought. Next time you sit down in that freezing cold exam hall, the clock starts and you turn over that paper, will you just see a chaotic, overwhelming wall of questions? Or will you finally see the code behind the matrix? The patterns are there, waiting for you to decode them. Keep practicing, stay focused, and I will see you all in the next masterclass.